Hello dear students, in this lecture we are going to see the region of convergence of Z transform. What exactly Z transform is that we have already discussed in last video. In this video we will see the concept of region of convergence. So xz, that is any signal which is Z transformed, is indicated by xz. Xz is equal to summation n is equal to minus infinity to infinity xn z raised to minus n. This is the definition of Z transform that we have already discussed. Evaluating xz as complex number, z is equal to r e raised to j omega. The equation becomes, we just have to put z is equal to r into e raised to j omega, because in last video when we discussed the definition of Z transform, we have already seen that z is a complex variable. So if I put this z is equal to r into e raised to j omega, the above equation becomes x into bracket r e raised to j omega is equal to summation n is equal to minus infinity to infinity xn, that is given signal, into r raised to minus n into e raised to minus j omega n. So just you have to put the value of z is equal to r e raised to j omega, and this is, if we match this equation with the Fourier transform definition, then we can easily say that this equation represents the Fourier transform of xn r raised to minus n. If r is equal to 0, xz reduces to its Fourier transform. That is, if r is equal to 0, r raised to minus n becomes 1 and xn into e raised to minus j omega n, where limit starts from n is equal to minus infinity to infinity. This is the entire definition of Fourier transform. This Fourier transform definition and details we have already seen in the previous videos. So in this equation, if I put the value of r is equal to 0, this xz reduces to its Fourier transform. The set of z values in z plane for which the magnitude of xz is finite is called as region of convergence. The set of z values in z plane for which the magnitude of xz, that is Fourier transform signal, is finite, it is called as region of convergence. Now there are some properties of region of convergence. The ROC does not have any poles. ROC is nothing but region of convergence. That region of convergence does not have any poles. When xn, that is the given signal, is of finite duration, then region of convergence is the entire z plane except possibly z is equal to 0 and or z is equal to infinity. If xn is a right-sided sequence, then ROC will not include infinity. If xn is left-sided sequence, then the ROC will not include z is equal to 0. If xn is causal, then ROC includes z is equal to infinity. If xn is anti-causal, then ROC includes z is equal to 0. If xz is a rational, then ROC extends to infinity, that is, the ROC is bounded by poles. These are some of the properties of region of convergence. Thank you for listening.